So this is x minus 2, and this is x plus 3, and here you don't have to write anything, or you write 1. So now, what is the numerator then? 5x minus 10 plus x plus 3 and minus 8. We combine like terms, 6x minus 15 over x plus 3 times x minus 2 equals 0 over 1. We cross multiply. We get 6x minus 15 equals 0, or x equals 15 sixths, or x equals 5 halves. My first thought is here. If 5 halves is on this list, then I will say no solutions. If it's not on that list, then I will say, assuming I didn't make an error. It's not part of the solution to check. It's not. But if you want to check, you should go back and check. But definitely have to at least check against the restrictions. Okay, the second equation. What type of equation is it? Yes, it's quadratic, and we have to apply it taking square roots. Excellent. So this is quadratic. Three x minus 1, everything squared equals 75. And although we have 4 different methods, we will definitely apply this one because it's typical for such a situation. So this is 3x minus 1. I have to write plus or minus, and I have to simplify the square root of 75 into 3 times 25. Very good. 5 the square root of 3 indeed. I move 1 and divide by 3. Any questions? The square root of x minus 3 plus 5 equals x. What type of equation is this? It is. Awesome. How do I what do I proceed? How do I proceed? What do I do? Exactly. In other words, I must isolate the radical. Awesome. Very good. And now? Now it's square. It's the inverse operation? Yes. What do we have on the left-hand side? And the right-hand side? I can only refresh your memory that we have done this for 3 months and a half. Now you understand why I did this on the first day of classes? Because I don't want to talk about it again. We subtract x and we add 3. Very good. Minus 7, minus 4. Very good. Now, checking is part of the problem, part of the solution. I have to go back and check. So let's check 7. 7 minus 3. The square root of 4. 2 plus 5. So that's a yes. Now I have to check 4. Let's check 4. 4 minus 1. 4 minus 3. 1. Sorry about that. Square root of 1. 1 plus 5. Is it 4? No. We're working on this and we're right here. Next problem. At least if we finish the first two tests, I think should be okay because the last one, yeah, is, yeah. So I think we can at least do that. Okay, next one. So the absolute value of 2/3 x minus 6 equals 2. What type of equation is this? Very good. So what can happen here? What can I have in here so that the absolute value is 2? What can this number be? Or 2. Very good. So there are two options. 2/3 x minus 6 equals 2, or 2/3 x minus 6 equals negative 2. Very good. So from here we have that 2/3 x equals 8. And we multiply both sides by? Very good. Indeed, 3/2. So from here we have x equals, I prefer to simplify. I don't want to multiply and then divide. 12. And from here we get 2/3 x equals 4. Or 2/3 x equals 4 multiplied by 3/2. And I simplify. Indeed. Next one. X over 6 plus 1/8 less than or equal to x over 2 minus 3/4. When I get news like this, I'm happy that I'm here with you. So what type of inequality is this? Say it again. It's rational only if it has x in the denominator. Linear indeed. Awesome. Degree 1, so it's not in the denominator, so it's yes. So I would like to eliminate what? All fractions. So what do I multiply by? So yes, so let me say it again. Perfect. Let me just show how we get 24. 6 is 2 times 3. Prime numbers always. 8 is 2 to the third. 2 is 2, and 4 is 2 squared. For the least common denominator, remember, I have to write all different factors. Don't look at powers. Different factors. 2 times 3. Now I have to choose the highest power for 2. 3. Now I have to choose the highest power for 3. 1. And that's how we get the 24. So we factor everything using prime factors. All numbers, all denominators, using prime factors. Maybe I should have written this, that this is 6, and this is 8, and this is 2, and this is 4. And all different factors have to be in the least common denominator. And since 2 has 1, 3, 1, 2, I have to choose the highest power. The same thing for 3, but it only appears 1, so it's 1. So now 24 divided by 6, what do we get? 4x plus 24 divided by 8. Very good. Less than or equal to. 24 divided by 2. 12x minus 24 divided by 4 times 3. Okay, and now this is more human. Once we eliminated the denominators, then this is becoming very simple. I move 12, I move 3. So I bring in a negative 12. 4x minus 12x, negative 8x, less than or equal to, and I move 3, negative 21. So this is x 21 divided by 8. Now what? Why? I'm dividing by a negative number. Awesome. So then x is in the 21 over 8, comma, infinity. Okay, next one. Negative 3 less than or equal to 2x plus 5 divided by 3 less than 6. When you review your previous test, you will see these problems are there. Pretty similar. Okay, so this is a compound inequality because it has two inequalities, one and the other. So what do we need to do next? Exactly, we eliminate fractions again. So then we have negative 9 less than or equal to 2x plus 5 less than 18. Very good. Subtract 5 from everywhere. So negative 14 less than or equal to 2x less than 13. And final step, divide both sides, all three sides by 2. Okay, so negative 7 less than or equal to x less than 13 halves. So negative 7 comma 13 halves parenthesis and bracket and x in. Any questions on this one? The absolute value of 3x plus 2 greater than or equal to 3. Remember we have two, what is this? And what type of inequality is it? Good. So remember there are only two types. One that is this and one that is this. This one is nice because you can use it as a chain, like this. But the other one is completely separate. With a union, exactly, exactly. So which one is it? It's the one with the union. Very good. So then I have to separate into two different inequalities and not forget to put the union in the answer. Awesome. Excellent. Yes. To the left of negative 3 and to the right or to the right of 3. Very good. Yes, if this has the equal sign, both of them have to have the equal sign. Okay. If this one does not, both of them cannot have it. Okay. None of them. So this is 3x greater than or equal to 1 or x greater than or equal to 1/3. And this one, 3x less than or equal to negative 5 less than or equal to negative 5/3. And now please give us the solution, anyone with a union in between.
Infinity, negative 5/3.
Negative infinity to negative 5/3.
1/3, comma.
1/3, comma, infinity. Very good. Next problem, the difference quotient. So we have f of x, negative 2x squared plus 7x minus 11. And we're asked to find the difference quotient, which we know is f of x plus h minus f of x divided by h. Which piece I have to work on? I have 3 pieces here. 1, 2, 3. Say it again. Yes, this one, right? This is clear, right? The function is here, and h is h. So the one that I don't have yet is f of x plus h. So how do I find f of x plus h? In the same way I find f of 5, or f of 10, or f of 15. Same way. Just tell me what to write. So remember, this is what the function is telling us. F of blah is negative 2 times blah squared plus 7 blah minus 11. This is my blah now. So it's minus 2 times blah squared plus 7 times blah minus 11. Is that clear? Please say no if it's not clear, and I'll explain again. Yes? 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 Jade, is that okay? Should I explain? Okay. This function says f of whatever you want equals negative 2 times the same thing squared plus 7 times the same thing minus 11. Now I have x plus h. Better? Everyone? Okay. So from here I have to continue, simplify it to the fullest. Negative 2, here it is, again, after 3.5 months. Very good. Plus 7x plus 7h minus 11. Only now I can distribute negative 2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 11. Let's stop for a moment and let me ask you a question. If you remember, what has to happen every time we determine the difference quotient for any function? 2 things must happen always for any function, anytime, the difference quotient. What is that? What are they? First step, or first thing that has to happen is all terms from the top without must go away. If they don't go away, something is wrong. And what is the second thing that has to happen? H from the denominator must go away. So 2 things for the difference quotient always. All terms without h must go away. If other terms go away, that's a bonus. I don't care. It may or may not happen, but definitely all terms without h must go away, and eventually h in the denominator. Okay, so we're ready now to put together the difference quotient. I replace this piece by all this. Negative 2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 11. I only completed this. Now I distribute negative 1 to these 3 terms, and I get positive, negative, positive. Plus 2x squared minus 7x plus 11 divided by h. All terms without h must go away. Let's see if they do. 1, 2, and 3. Age is in these three terms. That's why, and that's how the age in the denominator gets lost. Simplified, I meant. So this is negative 4x minus 2h and plus 7. This is the first term, this is the second term, and this is the third term. And that's the final simplified form. As you see, age is still in the problem, but not the one from the denominator. That got simplified. Any questions? Any questions? Okay. The piecewise defined function f of x equals 4 minus x squared, x less than 1, and x plus 5 for x greater than or equal to 1. Whenever I'm asked to graph a function, what is the first thought ever? Always exactly. Without the domain, I don't know where to start. I don't know what to put in the table. I'm lost. The domain is the starting point. Well, this is clearly negative infinity to 1, and this is 1 with a bracket to infinity. Now from here we can identify the domain, I think. All the numbers indeed. So then I can start my table. Negative infinity to infinity. 0 will always be in the table, any table, but this time has the important x value is 1. I know you remember that we are going to put a symbol, which is a parenthesis facing this way, and a bracket touching it, a bracket facing that way. So parenthesis and bracket. And we know what they signify. The parenthesis will signify ultimately an open point, and the bracket a full point. So again, as you remember, this is an overkill, but it's wise to have them up there. Because these two branches may be reversed. Who knows? There may be something tricky in there. So now let's analyze a little bit 4 minus x squared. What is the base function for 4 minus x squared? X squared. Then what is the next transformation in order of operations? Exactly, the negative, right? And then up 4. So I know how it looks like, right? Already, that piece. Good. So let's also look at negative 2 and 0 and 1. So let's plug in negative 2. How did I choose negative 2? Because 4 minus x squared will be 0 at 2 and negative 2. But 2 I cannot plug in because 2 is here. And it belongs to this function. So when you plug in negative 2, what do you get? 0, very good. Let's plug in 0. We already know we have the picture, right? X squared, negative x squared, up 4. Right, so it has to have the y-intercept 0, 4. And let's plug in 1. So it's 3 right here inside the parenthesis. On the other side, let's plug in 1. Very good. Let's plug in 2. That's it. Negative 2, 0. 0, 4. 1, 3. Open or full? Very good. And remember, we have the graph already, the image of the graph, right? X squared, negative x squared, up 4. Now the other side, 1 comma 6. Full point or open? Very good. And 2 comma 7. Oh yeah, in the middle there is no discussion. The discussion is only under 1, whether it's an open point or a full point. So can anyone identify the range for us? Say it again.
Negative infinity to 4.
Negative infinity to 4.
And 6 to infinity.
Union 6 to infinity. Awesome. Thank you, Kyle. Any questions on this problem? Moving on to 5. It's a yes? Okay, let's move on to 5. So it says in 1980, 21%, they were liberal. In 2010, it increased to 27%. The relationship is linear. And 1980, so X is number of years after 1980. What does X mean for 1980 then? Yes, very good. Find the linear function that fits the information, and then find when the percentage is 50. Any more paper? Good. So what is given to us? Every time I hear linear, what do I think of immediately? Say it again.
A line.
Yes. And then what do I really think of if I'm asked to find an equation of a line? What do I have to have? Every time we talk about a line, what do we have to have? Exactly. I have to have points, right? Okay, let's see. Do we have points? I always hope for points when I'm, or coordinates or ordered pairs, right? I always hope for that so I can find the equation. So do we have any points?
0, 21.
0, 21.
And 3, 27.
Um,
I guess 1, 27.
so from 1980, which is 0, to 210, 30, 27. That's it. That's all I need. So in order to say it again. So then what do I do now in order to find the equation of the line passing through these points? Find the slope, indeed. Very good, thank you. 27 minus 21 over 30 minus 0. So 6 divided by 30, or 1/5. It means nothing without the measurement unit. So let's find the measurement unit. The measurement unit is a ratio of 2 measurement units, one from the top and one from the bottom. So top over the bottom. So measurement unit for the top. What is the top given in? Percent of students, blah, blah, blah. Very good. Over. What is the bottom given in? What is the measurement unit for the bottom? Very good. In other words, the percent increase, the percent increases by 0.2% of students who are liberal in such and such increases per year by 0.2%. Good. Next, I have two options. I have y equals mx plus b. Don't forget the test, the final exam on Tuesday. Thank you. Thank you. Y minus y1 equals the slope times x minus x1. So,
X plus B.
yes, why would I use this? Although if I use this, I'm not going to make an error. But why is this more convenient than this?
So you have the slope on the right.
Because I have the y-intercept. 0, comma, a number is the y-intercept, which means I have b, which is 21. So then y equals 1/5 x plus 21. Will I make an error if I use the other one? No. You will get the same answer, but you will have more work to do. Find when the percentage of college students who are liberal increases to 50%. How do I find when?
Set 150.
Very good. So y equals 50, 1/5 x plus 21. I subtract 21. I get 29 equals 1/5 x. And of course, I multiply by 5. 145 years since 1980. This is the slope-intercept form. So we were able to use this because we had 0, comma, a number. But you can use 0, comma, a number in this one, and you'll still get this. Yes, slope-intercept form. Sure. Okay, next one. Number 6. Ready? Is this graph of a function, the graph of a function?
Yeah.
By the vertical line test, this is a function. Very good. The graph does not extend to the sides. Find the domain and range. So from 0 to 20 is the domain. And since this is -5, -6, -7 to 7. So domain 0 to 20, range -7 to 7. Say it again. So the range is from the lowest y value till the largest y value. And the domain is from the leftmost point till the rightmost point.
Okay.
Better?
Yeah.
Find the intervals of increasing, decreasing, and constant. Is this function ever constant?
No.
No. So it's increasing, increasing, and decreasing.
Increasing from 0 to 5.
Indeed, this is the interval on which the function is increasing. Union. Yes. F increasing on 0 to 5, union 15 to 20. And F decreasing on 5 to 15. Remember, we are only focusing on the trend. We are not interested from which value to which value. We are only presenting for what x values that happens. Next question. Find the x and y intercepts. So I see this point, I see this point, and I see this point. So this is 0, 0, this is 10, 0, and this is 20, 0. 3 x-intercepts. How many y-intercepts?
1.
That's not possible more than 1 because it will not be a function, correct? So it's this. So I will write for the x-intercepts 0, 0, 10, 0, 20, 0, and for the y-intercept only 0, 0. Relative max, min, yes. So there is a relative max here at 5, 7, and the relative min here at 15, negative 7. 5, 7 relative max, 15, negative 7 relative min. Is this function symmetric? A symmetric function has to have something on the other side of the y-axis, either even or across the origin odd. No, this function is not symmetric. None of the above. Find the x values when f of x is negative 5. So I have to draw a horizontal line at negative 5. So y equals negative 5. I see it crosses the graph in 2 points, and I will be reading the corresponding x values. And I see 12.5 and 17.5. X equals 12.5, x equals 17.5. And final question here, we're asked to find f of 7.5. Okay, 7.5 is here. It crosses the graph at this point, and I will read the y value. And I will read 5. Any questions? Bless you. Is this okay? Okay, next problem. So we are now into test 2. 1 minus x divided by 2x plus 6 greater than 0. What type of inequality is this? It is definitely rational. It has a fraction. It has x in the denominator. No question about it. Rational. Very good. So is it table ready? So remember, this side has to be a product or ratio of factors. And it is. And this side has to be 0. So then we have x, 1 minus x, 2x plus 6, and the ratio, 1 minus x, 2x plus 6. So now we need the corresponding x values, right? X is the variable in the problem from negative infinity to infinity, and I have to pick the zeros, or find the zeros. How do I find the zeros? For each factor separately. Correct. Awesome. Yes. So I have 1 minus x equals 0. What do I get for x? I move negative x to the other side, becomes x. So x equals 1. Very good. And then 2x plus 6 equals 0. X equals, move 6, it becomes negative, and divide by 2. Very good. And you have to put them in the correct order. Negative 3 and then 1. Obviously, there is a 0 here and a 0 here. But now I need you to tell me what do I write under negative 3 corresponding to the ratio, and what I write under 1 corresponding to the ratio. In other words, when x is negative 3, what does this equal to? When x is 1, what does this equal to? So I can put these in here. Which one? Careful. It's a ratio.
That's right. Undefined.
Where?
For,
Very good. Indeed, when denominator is 0, the fraction is undefined. When the numerator is 0, the fraction is 0. Very good. Awesome. Good. Now let's study the sign. Remember, when the leading coefficient is positive, the linear function looks like this. From negative, crosses the x-axis, and positive. But what about this one? This one doesn't have a positive leading coefficient, but it has a negative leading coefficient. So it's coming from crossing the x-axis to negative. Very good. When I divide a positive by a negative, I get, when I divide two positives, and only now I'm asking myself, what do I want? Which sign is greater than 0? That's the one I'm going to pick. Which sign is greater than 0? Positive. Is this ratio ever positive? For which x values? Very good. I cannot include either one. I cannot include -3 because it's undefined. I cannot include 1 because there is no equal symbol. Is that okay? So in number 8, I was asking my students to choose a function. Not graph both, but just choose one. If you want to do both, we can do both. Yes? Okay, very good. So f of x equals 2 times x minus 2 over x minus 2 times x minus 1. Obviously, I have to fully factor everything before I even look at and do anything else. Okay, I'm asked to graph this function. What do I do? When I'm asked to graph any function, what is my first thought? Always. I have to find what? Very good. That's why I factored it. So what do I have to exclude from this function? Very good. Excellent. Now I'm allowed to simplify it. I stated the domain. Now I'm allowed to simplify it. And now, what type of function is it? Yes. What type? Very good. It's a rational function. Very good. What type? Because we talked about 3 types. And if you want, I can refresh your memory on those 3 types. Okay, type 1 is same degree of a same degree. Degree 2 over degree 2, degree 1 over degree 1, degree 3 over degree 3. Type 2. What is important about type 1 is that the horizontal asymptote is the ratio of the leading coefficients. For type 2, higher degree, stronger in the denominator. The horizontal asymptote will always be for type 2. 0, very good. And type 3, higher degree in the numerator by 1 than the denominator. Degree 3 over degree 2, degree 4 over degree 3, which does not have a horizontal asymptote. Which type is this? Is it same degree over same degree? Number 2, higher degree in the denominator or higher degree in the numerator? Say it again. What is the degree of the top? There is no x. If there is no x, degree must be 0. What is the degree of the bottom? 1. So degree 0 over degree 1. What type is it? Second one. Very good. So it is type 2. What will be the horizontal asymptote? Very good. Awesome. So let's start. Negative infinity to infinity, and you already told me what to exclude. One more time, what do I have to exclude? Very good. 0 must be in the table, 1, 2, and they are both excluded because the function is undefined at those values. You already told me that it's the horizontal asymptote is 0 because it is type 2, higher degree in the denominator than the numerator. Good, so can you please plug in 0 here in the simplified form? 0 here. What do we get? Divided by -1. Perfect. So now we have to establish what x equals 1 represents and what x equals 2 represents. So what do you think is the difference between x equals 1 and x equals 2? Obviously, they cannot be the same. Here's why. X equals 2 or x minus 2 went away. X minus 1 did not. So they cannot be identical situations. One factor is completely gone, and the other one I'm stuck with. So what is the difference between these two? What does the function have at x equals 2 where the factor went away? What does the function have when x equals 1 when the factor is still there? What do you think? If the factor went away, what happens? The function is still undefined. I can't change that. Say it again. Open point. Hole in the graph. If the factor went away, there is a hole in the graph. Now, if the factor stayed in there, what happens there? No. The turns and crosses are only for the x-intercepts. This is not an x-intercept. This is a point where the function doesn't exist. So what happens when a rational function is undefined at x equals 1 and factor is still there? What is it called? Exactly. So when the factor stays, it doesn't go away, the function has a vertical asymptote. If the factor went away, the function is still undefined, and that will have a hole in the graph. So now let's find these values here, left and right. Please plug in 2 in the simplified form and tell me what you get. Very good, on both sides. For the vertical asymptote, we know that they must be infinities, but what I don't know is what? The sign. Right. So let's put 0.9 and 1.1. Please plug in 0.9 in here. Just give me the sign. Indeed. Please plug in 1.1 and give me the sign. That's it. That's all we need. We're done. When we graph functions with asymptotes, what do we have to graph first? Correct. Yes, go ahead. Say it again. I just didn't hear you. Yes, the asymptotes. Very good. Sorry about that. Now, this is an overkill. There is no need for this, right? But x equals 1 is x equals 1, vertical asymptote. So now I'm going to plot the points. I only have 0, -2, which is here. And I have 2, 2, which is here. 0, -2, and 2, 2. Ready? From approaching 0 down to crossing the y-axis at 0, -2, approaching negative infinity on the left-hand side of the vertical asymptote. Okay, no problem. On the other side, from positive infinity going through the hole and to 0. Fine. So this is f of x equals 2x minus 4 over x squared minus 3x plus 2. Any questions? Any questions? Now, what type of function is g? You correctly identify the previous one as a rational. What type of function is g?
Cubic.
It's polynomial. Polynomial. What about the degree? This is degree 3, this is degree 2, and this is degree 1. 6 indeed. What is the maximum possible number of turns? Yes, it will not turn more. It doesn't have to turn 5, but it cannot turn more than 5. Max in turns. Good. How many x-intercepts will you give? Let's see what I discovered here. Oh. So g of x equals 0. How many solutions will you give? Exactly, the degree of awesome. Good. So please give me 6 solutions and their multiplicities. There is only one 0. Multiplicity 1. X equals 3 multiplicity. Good. And x equals negative 2 multiplicity. Very good. Awesome. What is the domain of any polynomial function? Yes. What is the domain of any polynomial function? Yes, friendly, no problems. In ascending order, negative 2, 0, and 3. These are all x-intercepts. Multiplicity 1, what does that mean? What does the function do? Multiplicity 1. Very good. Multiplicity 2 for x equals 3. Very good. And multiplicity 3 for negative 2. But what type? Slow. So it's a cross, but slow. If it's odd multiplicity, it always crosses. If it's even multiplicity, it will always turn. Think in terms of x squared. You know x squared has 2 solutions, x equals 0. And it turns.
So odd crosses and evens.
Always.
You wrote it back.
Say it again.
You wrote it back.
So negative 2 crosses is a cross slow.
Oh.
0, I'm checking. You may be right. Maybe you see something I don't. So I always go back and check. So it's good. So 0, 0. So multiplicity 1, regular cross. And at x equals 3, multiplicity 2, which has to be turned. Better? Okay, now let's think in terms of the end behavior. Since it has degree, one more time, degree 6, do we compare it to the line? Or we compare it to x squared? No, because the line is degree 1, odd degree. We're talking about degree 6, which is even degree, so I have to compare it to x squared or negative x squared. So let's look at the leading coefficient. What is the leading coefficient here? So is it going to look like this or like this? Right? Very good. So the end behavior is negative infinity to negative infinity. Okay, ready? I plot the points I have. Negative 2, 0, 0, 0, and 3, 0. Okay, here's what I see in the table. From negative infinity, it goes up, crossing here, but very slowly. It has to come to a turn because it comes back to cross at 0, 0. It has to come to a turn because it will come back and turn at 3, 0. One more time. From negative infinity, it crosses but slowly. It comes to a maximum and then crosses quickly. Comes to a minimum because it has to turn here because it comes back and turns again, according to this. So this is our function f of x, negative x, x minus 3 squared, x plus 2 cubed. Yes, I don't know this. Yes, I don't know this. And I won't be able to find them without the calculator. So let's do just that.